This example comes with section 8.4, log and exponential equation. For this next question, we're given a little bit of background information about carbon dating. You've probably heard of the term carbon dating before. It basically uses an isotope called carbon-14 that's radioactive and has a high half-life of 5,730 years. So our question is, if an archaeologist finds a bone that contains 19% of its original C14, how old is the bone? So they have some technology, some method of knowing how much C14 this bone should have had, and they know that it's down to 19%. So if you look at your formula sheet, you have an equation that looks something like this: y equals a times b to the t over p. And it says that that's useful for exponential growth and decay. But it doesn't tell you what a, b, t, or p are. And so that's kind of, well, is being left up to you. If you use this equation, you need to know that y is essentially going to be your final amount, or your current amount if you prefer. A is your initial starting amount. And so that might be, a bank investment. You invested $5,000, so that's A. Your current value is going to be Y. B is a little trickier. It's I call it your multiplication factor. Now, depending on what you're multiplying by, this B value changes. So in the case of a half-life question like this, the half-life means that our multiplication factor is a half. A lot of questions are doubling time questions, and so your multiplication factor is 2. It's multiplied by 2 every doubling time. But there are some questions, interest questions, for example, where something's going up 5%, so your multiplication factor is 1.05. We've done some of those in the past, and we'll run into some more in the future. Now, t is, I suppose, probably what you'd expect it to be, is time, the time that this thing has spent decaying in this case. In some questions, how long it's spent growing. And p is the period it takes to either double or half or whatever the multiplication factor is. So in this question, it's the half-life. So what am I looking at? I'm looking at the final amount. Well, the current amount is 19%, assuming, again, we started with 100%. The multiplication factor is a half, or 0.5, and the time spent we're not sure of, but we do know that the period for this thing to go in half, its half-life, is 5,730. Really, most students who get this formula or equation set up properly do end up getting it done properly in the end. It's just the setup that causes most people the problem. Can divide both sides by 100. We've got 0.19 equals 0.5 to the t over 5730. This could be done graphically, graph the left side, graph the right side, see where they intersect, or do it as a log problem. You've got log 0.19 equals t over 5730 times the log of 0.5. Allows me to leave t by itself, multiply by 5,730, and then divide by log of 0.5 to figure out what this time period is. So 5730 times log of 0.19, and then divide that by log of 0.5. And I got here approximately 13,729, and in this case it would be years. Our time is being measured in years. Now, I presume an archaeologist, I don't claim to be one, but they would probably give you their estimate is in the range of 13,000, 14,000, even 15,000 years. I don't think they quite make it as precise as 13,729 years old that the bone is, but following the math through, that's the answer that we got.